So I'll start things out, I guess, for Ken online and those watching online. Thank you for attending our meeting here, the Sacramento chapter of SMPTE. We're going to talk about, well, Robert Erickson's going to talk about creating hybrid on-premise and cloud-based media workflows. My name's John Hinkle, by the way, one of the committee members here. I work for Netgear, moved up here about 5 years ago. So one of you now in town, you may see me at a grocery store or something. We do want to thank Ramona, of course, wherever she is. Thank you, Ramona, and Nevada County Media for having us all here. Just to know, make sure you know who is who here. Bob is our chair. Mona Smothers is not with us this evening, but she is normally here. Jed Dean, myself, Robert Erickson, of course, on the panel this evening, John Laron, Victor, who is here as well. And we have a seat open, so we would like some more participation from someone if they want to join us on the manager section of the board. Our past chair, of course, is Paul Turner, so can't forget about him. No, we can't. So as I mentioned, there's an open manager position open for next year. There isn't a whole lot involved, really, trust me. It is helping to set some agendas, get some speakers on tap for some of these programs, but it's good to get out of your home office. That's my reason for being here, for sure. It's good to get out and be amongst real people who share some common goals here. And I think SMPTE's doing some good stuff. I was on a meeting earlier today, I guess, on the advisory committee or something, and they really are talking like, how do we get more youth involved? Things like that. It's not just a bunch of us, well, a bunch of old white guys like me. And those are things we need to all work on, especially up here, getting younger people at AGA or Telestream or whatever involved here. So we could use some pointers for that for sure. And then Bob and Mona, this is going to be their last year. Is that 2024 this last year, or 25 is the last year? Till June. So we need some help. We'll need some new help on the board. And if you have an interest, let us know. But without further ado, let's talk about tonight's presenter. And I met you for the first time. We've crossed paths many times, but I'm going to read some of this from here. You see on the screen. Currently Vice President for Sales at TAG Video Systems, member of TAG since 23, but tons of years experience in broadcast and IT markets, network design, systems engineering. So he knows his stuff for sure. I know many of you know him, but some haven't met him yet before. You were not here in the Bay this area before 23, is that right? Or
I lived here from 2008 to 2011.
Oh, that's what it was. You came back. Active participant, you've probably seen his other presentations from SPE or STE, SMPTE, of course, as well, and the Hollywood Professional Association. So lots of experience presenting in front of customers and fellow engineers and the like, and that's why he's here. I think that's it for this particular slide deck. Let's go over to the actual presentation, and I'll turn it over to you.
So about 2 months ago, when I committed to doing this thing, apparently about half the other speakers started wanting to talk about hybrid media workflows too. So I was like, you know what, if we're all talking on the same topic, and I haven't given a presentation in a while, why not just go out and do something a little more aggressive, do something a little more progressive, and maybe make some people angry, or at least get some people talking. So that was my point to this presentation. So we're going to kind of talk a little slowly into what are hybrid media workflows and why they apply. Then we're going to go off into some new stuff that the EBU, of all people, is working on right now. They just released some stuff that I hadn't seen until about a month and a half, 2 months ago, about how to do media workflows in a hybrid on-prem cloud environment. So because of that, the point of the presentation is to be a little progressive and to talk about some stuff that doesn't quite exist yet, kind of forward thinking, where this industry is going, where we're going to be in 5 or 10 years. So if you all have any thoughts, because we do have a smaller group and as much time as anybody wants to invest in it, it's a 30-minute presentation. So if you want to go longer than that, ask a lot of questions, give a lot of opinions, and I'll be glad to defer to smarter people on the answers. So
asking Ken if it sounds okay.
Hey, Ken, is it better now that I'm close to the computer? It's not.
Yes, I can hear you just fine. Thank you very much. I appreciate that.
Hey, I got your back. Again, I appreciate you remoting in. All right, so next stop on this one. Clicker is not clicking.
Technical difficulty.
That's right.
Please stand by. Manual way.
There we go. We'll go old school. Oh, there we go. Now we're back. Okay, so first off, what do we mean by hybrid environments? I think most people, well, you're at Telstream, so this doesn't affect you. And sorry, Mike. Okay. And Victor and I, by the way, we work together. We actually work for a company based out of Israel and didn't know each other until we started working for a company in Israel, even though we both live in and around Grass Valley. Small industry, right? So he's in the same boat I am on the software side. But what do we mean by hybrid environment? Well, traditionally in the broadcast domain, when you do a workflow, and what do I mean by workflow? I'm taking a camera and sending it to a production switcher, and a production switcher is creating a show. Or I'm doing a file-based workflow. I'm doing something with media that does something, just a functional process of media. I try to keep it very generic because that is kind of the intention of this. So when we're talking about workflows in hybrid environments, it's how do we create a broadcast workflow, again, whether it's file-based or live or play out or distribution or whatever it happens to be. Again, doesn't really matter to the point of this presentation. But the big part is traditionally in broadcast, we've done it on-prem. You know, we've seen racks of servers, you've seen FPGAs, racks and racks of FPGAs, you know, that are stitched together to create a production switcher, or FPGAs and stuff that's stitched together to become a router, or things like that. Those have been traditionally large amounts of hardware stitched together to create workflows. We're getting to the point now where we can do most of those workflows in software. So this is what we're here to do best. So in short, we want to be able to use the compute resources exactly where the workflow requires it to be. Now, traditionally, because of just how things had to work, they've always been on-prem. Just what it was. I mean, you have hardware, you have FPGAs, you have ASICs, you have everything that comes along with making hardware work. But once you go to software, why do you have to have all your gear and all your compute in your facility? Especially if you maybe want to spin up some productions. Maybe it's like a fast channel. Maybe you want to be able to bring a new playout channel on the air and you want to test the markets for a little bit. You know, I want to spin up a channel. I want to try it for a month. One of my kind of favorite things I love to see is like Roku. Do you guys, anybody here have a Roku TV? So if you have a Roku, there's the most fantastic channel. It's Modern Marvels. Do you guys remember that show from cable? It's Modern Marvels 24/7, 365. And the company that owns the assets, that is Modern Marvels, said, you know what, we've got like 30 years of content. Why don't we just spin up a fast channel and see who watches it? Well, next thing you know, like 50,000 people are watching this thing all the time. And they actually were able to have enough of a revenue stream to justify that fast channel. So we're starting to see, you know, people spinning up workflows just to test the waters to see what it is. Because if I can spin it up in AWS, I'm not investing millions of dollars in hardware. Why not try it? But why can't we now do that with live production workflows? Why can't we spin up something for the local high school football game in the cloud, try the production out, shut it down when you're done, instead of having to spend hundreds of thousands of dollars on hardware? So we're trying to find ways to use the new compute resources that we have. This is a very complex and very hard to read because the projector I was using previously was a little bigger. But what we're seeing here is a very good example of a hybrid workflow. This is an entire production workflow stitched together where we have cameras that are on-prem 2110. 2110, by the way, is fantastic because it's really high quality. But could you imagine this camera putting out a 3 gigabit per second signal, getting that to AWS, and you got 30 cameras? We're going to dive into that a little bit more. So you have on-prem cameras where you want the highest quality resolution. You want the lowest latency possible. Right now, the technology just requires it to be on-prem. You have cameras on-prem. Now, we have a lot of places now that are converted to J2K or JPEG XS if you want to be a little more modern, where you have very low latency codecs, you know, 40 lines of delay, 60 lines of delay. It's still pretty big amounts of bandwidth, you know. It's a 10-to-1 compressor, 15-to-1 compressor. 3 gigabit signal comes down to 250 megabit or something. Still a lot, but it's not near as bad as uncompressed. So we're starting to see some stuff in the middle here for the customers that have basically more bandwidth and more money than God. They can do the JPEG XS stuff. But then, if you look at all the distribution today, almost all distribution in the cloud has been for years. And so if you want to be able to look at content, you know, if you want to be able to have a director that isn't at that facility, maybe that director wants to be at home, because why does the director have to be at the facility now? If they can see all the multi-viewers, so they can get all the comms, all the audio from home, well, why do you have to pay for that first class ticket and the $500 night hotel for the director to fly out? Why not just send it up to the cloud as WebRTC and send it out? We've been doing this for years. You know, this got really popular in 2020. Same with some replay operators and so forth. So we're starting to see, we got Zixi and NDI and SRT and WebRTC, all this kind of things. This is a workflow that everybody uses today. This is a very commonly used hybrid workflow. And there's no reason, by the way, this can't be SDI. I'm not saying this has to be IP, but these are the type of hybrid workflows we're seeing. But this really is designed by a customer that has more money than God. It's, when you're talking native IP cameras, native IP switchers, especially in the uncompressed domain, it's just the costs are astronomical.
Are they actually using Zixi, NDI, and SRT in the same installation?
Yeah. Yeah, because all of them play their own. They all kind of play in their own little domain. Like NDI is fantastic because it's supported by a lot of consumer grade stuff, but it doesn't work. Well, the newest NDI now works over WAN, but historically NDI doesn't work over WAN. It only works over a LAN. So what customers have been doing is if they have multiple pieces of software in an AWS environment, the best common protocol to speak inside of an AWS area was NDI because everybody supports it. So we see a lot of NDI being used to connect software in cloud environments. Now SRT and Zixi, those are designed to be WAN usable. SRT and Zixi both have things like FEC and ARQ, things in the software to kind of give you highly reliable video over less than reliable connections. So yeah, we're starting to see now where our customers are wanting to use the exact transport to make that workflow work for them, which is also why we've seen WebRTC take off. WebRTC is extremely low latency. It's wrapped up in HTML5, has no problem with busting through firewalls. We're starting to see the technology progress a little bit. So, yeah, so this is kind of a big example of it. But as I addressed a little bit, you want to use the compute exactly where they are. So when you use on-prem compute, that's just servers at your facility. You good?
It's going to scoot the mic over.
Okay. We're just trying to find a way to kill me by cable. So when we do things on-prem, you have a couple of big advantages. First off, 2110 is fantastic on-prem. Just think about it. You got your cameras are 12 gigabit per second or 3 gigabits per second. Your switcher's got 192 3 gigabit per second signals coming into it. You got multi-viewers. If you look at any production environment in 2110, 50 to 60% of the bandwidth is for multi-view. It's the reality of it. So you have a lot of bandwidth, but what do you get from it? Very low delay, lines, and it's uncompressed. Quality is fantastic. So, and also being on-prem kind of supports the legacy software. Any software that's been on-prem for the past couple of years, obviously is going to continue to work on-prem. You don't have to do anything special to get software to work on a server. Pretty good chance it's designed on that server in the first place, right? So we don't have to do anything special. And a lot of our customers love the CapEx model. I'm going to invest $1 million in Dell servers. I'm going to amortize that over 7 years. Once that's off the books, I'm going to replace it, rinse, repeat every 7 years for eternity. It's a capitalized model. It's what they're used to using. Now, it also has disadvantages: maintenance, power, and thermal. Now, when we think about compute, we can even go as far, it's a bit of a stretch, but we can think of like an SDI router or 2110 router as a workflow engine. Has anybody looked at, I'm poking fun at SDI, it's a very dramatic thing to talk about. Has anybody looked at the power efficiency of an SDI router? So it's the inefficiency, you're taking in a bunch of SDI inputs, 1 volt peak to peak, put in a bunch of 1 volt peak to peak outputs, but in the meantime, you've got 16 power supplies that require 1300 watts per power supply. So your power efficiency is somewhere around 0.0000, I think that's the last time I did the math, 1, right there, because all that power is going into creating a whole bunch of 1 volt peak to peak outputs, right? Not exactly the most thermal thing, but in all fairness, computer servers aren't much better. In all fairness, per RU, you're actually using way more power to do Cisco switches now. You're doing way more power to do Dell servers or HP. Even if you go down the blade rabbit hole, it's not like the servers are using less power. The power density goes up exponentially. So there's significant power, significant thermal, and so forth. And so when you think about this, well, why is this a problem? If you're NBC And 15 years ago, your job was to make maybe 16 linear channels worth of media. You built your rack room to be able to do that much. Now your requirement is to do 400 to 500 channels, some linear, many not, many VOD and so forth. The amount of equipment that you need to process that much more media, it's a lot. And so your power density is going through the roof. So thermal is becoming just almost as big issue now as anything else in the broadcast domain. How do you control the energy in? How do you control the heat out? So on-prem, that's actually becoming, go to 30 Rock. That's one of their biggest issues right now is how do they cool the gear? How do they get enough air conditioning in there to do it? Other places like Disney, they were actually already having that problem. Then a developer said, we'd like to buy your land. And like, thank God. And then they moved because now they're able to build new data centers with more cooling and things along those lines. That's such a huge issue right now. So duty cycle is another really big one. If you're out to build a media factory, how much do you want to be able to use your assets? You know, you think about, let's use Sacramento, let's use KCRA, for example. KCRA does 8 hours of news a day. Last time I checked, might be 9, but they did 8 or 9 hours of news a day. So that millions of dollars they've spent is only used a third of the time. It's not a great duty cycle. I mean, it's not bad, don't get me wrong, but it's not a great duty cycle. You'll see studios in New York City who will build a $10, $15 million studio to do one hour show a day. So the duty cycle, the amount that gear is actually used is pretty awful on-prem. Getting better. Once we went to IP, we're actually able to virtualize resources and use it a little bit better, but still not that great. And also, downside is it is still a CapEx model. If you want to try new production, just to see if you can do it, see if the market wants to do it, you still have to invest a couple $1 million to be able to spin up all the production assets to do it. So that's why we've seen everybody kind of pushing really hard on cloud recently, because now I have complete dynamic resource allocation. I can spin up the exact amount of compute that I need. If I need 32 cores on 2 CPUs to do a production, that's what I spin up. Because now, if I want to spin up a production switcher that has 6 inputs and 1 output, because that's all I need for my production, I can. You pay for whatever the software licenses are, you pay for whatever your AWS or Azure or GCP compute is, and you're there, you're done. It's fantastic. Also, geographic optimization. Think about, let's just go down live production before we go to distribution. On live production, if I'm sitting in Los Angeles and I'm using a data center, maybe it's on-prem, that's in New York, I'm going to have some latency inherent to physics, time of flight of photons to get from LA to New York and New York to get back, right? So I'm going to institute quite a bit of latency along those lines, and also higher probabilities of failure and so forth. So if I'm in Los Angeles, I'm just going to use an AWS node that's in downtown LA over at LA1. My latencies, I actually have a buddy that does exactly this, and he lives in downtown LA and uses the downtown LA AWS node, and his ping time is regularly between 4 and 5 milliseconds. That's including propagation, that's including switch time. That's imperceivable to the human eye. We've kind of taken propagation delay out of the equation when you do that. So you can have geographically optimized stuff, but think about it also for distribution. If I want to be able to do a show that I know is going to be huge in Sao Paulo, Brazil, but nobody in LA is going to watch it because it's in Portuguese. You know, they might have like 5,000 people in LA watch it. Why would I build my infrastructure in LA just to be able to have to pipe it all the way down to Sao Paulo, Brazil? Why don't I just spin up my production assets in Sao Paulo and call it done? So this applies to live and distribution and OTT and VOD. This applies to every aspect of media workflows. And also it's OpEx. I already talked about this one a little bit. You know, if you want to spin up a channel just to see if the promotion model works, go for it. You know, you pay for some software licenses. If you're working with a software vendor that'll allow you to OpEx it, you literally just have whatever sunk cost you have for the compute and the OpEx licenses, and then when you're done, you shut it down and that's it. It gives you actually a way of testing the waters, trying new workflows, trying new things you currently couldn't, or you historically couldn't do because of the costs incurred. But it does have disadvantages. High bandwidth workflows are challenging. There actually is one company, which is funny to me, who is focusing on doing multicast 2110 in the cloud. We'll see how long that business model works. I like the company, I like the people a lot, so I don't want to say anything bad about them. But how practical is it that we're going to be sending dozens, maybe hundreds of uncompressed 2110 or even JPEG XS into the cloud? You know, again, 10 to 1, 15 to 1 compression is great, but it's still massive amounts of bandwidth. And what do you get? You get low latency. Is the cost of having inflexible infrastructure? Is the cost of extraordinarily expensive pipes worth a couple of frames of latency? That's what the market's trying to figure out. That's what we're having to deal with. So, also legacy software is really inefficient in AWS. I'm sure y'all have heard of lift and shift, software that's been written to originally designed to run on Intel x86s and do their one job on their one little pizza box server. That software is horribly inefficient when you push that into the cloud. I'll use a tag product just because I work for tag, and if I'm going to make fun of somebody, I'll make fun of myself. So we have a product, it's called the MCM, and the product is a monitor and a probe and a multiviewer. Basically, any video and audio that comes in and out of the box, we'll measure hundreds of test points against it. What's the quality of the video? What's the quality of the audio? Is the transport stream healthy? All this kind of stuff. And also, we make a pretty good multiviewer out of it. Every MCM install you do comes with a database local to it. So if I use one MCM, great, I got one database. But we've got customers using 600 to 700 MCMs, which means those customers have 600 or 700 local instances of database running on each of those boxes. How efficient is that in the cloud to have 600 instances doing the exact same bloody thing? So that's what you have to watch out for, is legacy software architected in legacy manners tends to get very inefficient because you're going to pay for compute for every one of those databases you're running. So, by the way, we fixed it. That's not a problem for us, but I'm using us as the example of how not to do things. Again, we fixed it. Just to be very clear, because also he has to deal with it, and I'll hear it from him tomorrow if he's like, we fixed that like a couple months ago, right? So, also the disadvantages. OpEx is also very much a disadvantage. One thing that's interesting we're seeing in the industry is over the past 3 to 5 years, AWS and Azure were giving the big broadcasters and the big sports networks billions of dollars in credits to get them on the platform. And there are always 2 to 5 year deals. We're now seeing those 2 to 5 year deals expire. And now we're starting to see some of our broadcast customers are in the dozens of millions per month in compute in AWS and Azure. It's a big hit, especially if you can capitalize it, put servers on-prem and kind of get the same thing. So getting to that point, so where are we now? How do we get to this true hybrid place? Because maybe things that are going to be using an insane amount of compute, why not put them on local on-prem servers, but then be able to use cloud-based instances or remote-based software instances to be able to plug the holes in your workflow where we need them to be. That's a very pragmatic, practical, and cost-effective way of doing it. So how do you do it? And this is the part of the presentation where I like to get people a little more annoyed, because part of this we've already done. Phase 1 is we have to remove the physical interface from the equation. If you're SDI or even 2110 to a smaller extent, you have to remove that from the equation, because as long as you have either a really high bandwidth connection, 2110, or physical connection, SDI, you can't virtualize your production. It's just impossible. And if our customers are going to be required to make more and more content with less and less people, having traditional hardware, traditional software in the traditional environments with physical interfaces just can't scale. We've seen it. So first off, you've got to remove the physical interface. What that allows you to do is you treat your media and all your media processors now as dynamic resources. Traditionally in the broadcast space, maybe I needed to do a 1080i to 720p converter. Well, actually, in that room over there, there's dozens of cards in there that convert 1080i to 720p, little modular cards, right? Fantastic. We still need to do that. We still have to convert 1080p to UHD. We still have to be able to do HDR to SDR. We still have to be able to write audio levels. We still have to be able to change the video gain. We still have to do all the processing we've always done. But now we need to be able to do it in a manner that we can get the asset utilization up and be able to treat it as a virtualized resource where anybody in the world or anybody in that workflow can require it, that needs it and requires it, can use it. So that's the next big step, is how do we treat all this? How do we make all these workflows and all these little individual processors that we need virtualized? So we started it with SMPTE 2022-6, and it has since evolved into 2110. I put PTP on there because anybody who's been involved with 2110 knows you'll spend 80% of your life figuring out PTP, and the other 20% is actually relatively easy. Fair enough? Yeah, you're nodding your head, so you've been involved. I know you have. And Victor lives that hell all the time. So we got to remove the physical interface. And this is the part where I had a much larger audience last week, but I'll be one of the first ones to say our future is going to be compressed. There is no way around it. You know, the 2110 as we know it and as we have designed it will have a short life. You know, will that life be 5 years? Absolutely. Will that life be 10 years? Maybe. But it's going to go away eventually because 2110, for a couple of reasons, bandwidth, huge. Can't do anything about that unless you go to 2110-22, which just allows me to do that, you know, that's as well. So I can do compressed workflows inside 2110. But then I still have evil things like PTP that don't work very well in cloud, hardly at all in cloud environments, because PTP usually requires multicast, and you don't get multicast on the cloud. So our industry, as much as we may or may not want to agree to it, is going to move to compressed. And I didn't spend too much time on this in the previous one because the much larger audience and I had a very fixed 30-minute window. So if you guys don't mind me pontificating a little bit more because we don't have such a fixed window. You know, the industry has always been against compression for the years. Number one, for interop. You know, if I got uncompressed areas and JPEG XS areas here and J2K areas here and H.264 areas here, how can I guarantee that any of those sources can run to any of those destinations? You couldn't. So for interop, first and foremost, we stuck with 20 or for SDI or for 2110. Now we're starting to see JPEG XS proliferate quite a bit. You know, there's production switchers. Grass Valley, I think, had the first one that supported JPEG XS natively. We're seeing other people do it. Pretty much any multi-viewer processor now supports JPEG XS. So we're seeing JPEG XS get out there. You know, they kind of got behind that. But again, that's still relatively high bandwidth. But once you get into a software domain, if it's a properly architected solution, you don't necessarily have to care what the transport is. And before anybody pops off, like, well, that's not really realistic. Well, I'll use tag for an example, which is as close to an ad as I can get with SMPTE, by the way, because you know you can't talk about your products or sell your products with SMPTE. So this is as close to justifying the alcohol purchases tonight as I can get. You look at the tag media platform. We support it all. We can bring in 2110. We can bring in 2022-6. We can bring in NDI. We can bring in SRT. We can do HEVC. We can do J2K. We can do JPEG XS. We can't do VC1 or VC2. Sorry for anybody who wanted to trip me up on that. If you can, for the most part, if it's a transport stream or codec that's used today, we support it. And we're not the only one. You know, I happen to be on stage getting the free alcohol thanks to the company, so I got to promote us. We're not the only one that can do this. But this is one of the biggest things about creating workflows in software and cloud-based workflows is this traditional restriction of interop is now relatively gone because the software can adapt to it. We can throw any codec you want. Now, is there a question over there? Nope, just clearing his throat. Okay. So we now have an environment where we can kind of pick the codec for what the workflow requires. We can do 2110 if that's what it wants, but we can output it as WebRTC if that's what we want. And that's been a big change. That hasn't really kind of came to be a reality up until the past 12, 24 months. So if you can make the assumption, which as we've seen a lot of software programs already do this, that compressed workflows are fully supported, then why do we support it? Why do we need uncompressed? Why do we need extraordinarily high bandwidth connections that can't use public cloud, that are enormously expensive to propagate across different facilities? Why do we need it? Well, latency and quality. Fair enough. If I'm NBC and I'm going to add 3 frames of delay, but I can save $10 million a year, do you think I'm just going to tell my contract TD to get over it? That's kind of what they're doing. You know, the TDs are complaining. The replay operators are complaining because, you know, what is 3 frames? You know, 3 frames is right on the edge of what the human eyeball can decipher, right? Well, if I'm a replay operator and I've got 3 frames of delay on my multiviewer, do my dog shuttle wheel, I jog right to fast forward and hit play. That little 3 frame is actually enough to give a little bit of rubber banding effect and drive that replay operator crazy, which is why they're not doing it for the Super Bowl. They're still doing 21:10 for those. But every B level and C level game out there, I guarantee you today, those replay operators are at a building somewhere not in the field, because the value of that asset wasn't high enough for them to tell the replay operator, get over it. And that's what we're seeing. But also we're starting to see H.264 and HEVC codecs that are 1 frame of delay. 1 frame's not bad. You have to deal with cumulative delay throughout the entire workflow. But seeing these codecs now 1 frame of delay, pretty fantastic. So that starts to address, some of those issues. So next part is we got to remove the physical
Can
hardware.
I be so bold as to post a question?
Please, I would welcome it.
The question I have is, what about archival storage of master versions of events? If the source production is compressed, where do you get the highest quality reference for future reuse of that media?
So I can focus on sports and news today. And when you look at a sports production, Super Bowl, that kind of stuff, that area of ingest of content is actually in the replay machines. So it's already compressed today. Now they're doing 50 megabit, sometimes 30, but if it's UHD, they're doing 50, maybe 200 megabit for UHD, 50 megabit for 1080p. But right now, all the archival footage, both in terms of resolution and temporally, so like high frame rate, 180 frames per second and so forth, that is all currently stored in the replay system. And that is usually HEVC, again, 50 or 200 megabit. That's where everybody's pulling their archives from right now. So nobody's, I haven't seen an uncompressed. I mean, the cinema does a lot of J2K and JPEG XS stuff, but for broadcast workflows, it's cost prohibitive.
Thank you.
Yep. Yeah. Yep. But their cameras are still, they're not filmed. They're, they're still archived at some compression at some point. Yeah. So, yeah. And by the way, the problem gets so much worse once you start looking at high frame rate. Back when I was at Grass Valley, we were doing UHD at 180 frames per second, and that was 48 gigabits per second at 2110 for one camera. So it gets even more ridiculous once you start adding temporal resolution.
So does compression basically nullify the requirement for UHD? Because one of the original requirements for UHD was to be able to effectively zoom in on any kind of quadrant or section that you wanted to and have a perfect 3 gig signal from it.
Yep.
From a historical perspective, And so now if you're compressing everything, what are you really getting when you're zooming in?
So that's actually a really interesting point. Because, at 200, you're not giving up much when you're doing 200 gigabit per second, 200 megabit per second compression for UHD. You're losing some color data and a little bit of spatial data, but you're not giving up much. Now, once you start squeezing that like home distribution UHD, now they're doing 5 megabit, 8 megabit.
Sure.
That's trash.
Well, home distro doesn't even count.
Yeah. But at 200 megabit, you're still preserving a pretty good signal at 200 megabit. And that's, again, a lot of the archival footage is still doing AVC 200 megabit for a lot of the UHD stuff. So you can still pull a pretty good 1080p signal out of it.
Yeah. So would you say in these compressed environments that even though there's the capability to provide a variety of different codecs to handle a variety of different signals coming in, it always comes down to whatever the base and production layer can handle in order to actually edit the footage or to manage the switches between the sources, right? So there really isn't a product out there that says bring an HLS and bring in an NDI and bring the 2110 up and switch between them.
Oh, there is
I
no.
actually have, and I can actually have proper timing transitions between them with, being aware of time code, as it were.
Right. You're 3 slides ahead of me. The EBU just released a paper about this the end of September, early October-ish, that it directly addresses exactly what you just talked about. And it's 3 slides ahead. So yes. So I'll actually dive right into that because it's actually this point. I'll even go a little farther ahead. Legacy vendors are wrapping hardware around with IP interfaces, switchers and stuff with IP interfaces and so forth. But the interesting thing about when you just remove the physical hardware, it doesn't actually create any new workflows. You're just protecting legacy revenue. So when you're seeing existing products, there's a lot of router manufacturers today that have an SDI core, a baseband core wrapped around with some 2110 edges and some SDI edges, and logic convert between the two. Great, you're now in your IP domain. What new things can you do now? Because you're still a 3 gigabit per second signal. It's still really hard to process. You can't get it to the cloud. You're just allowed you to scale a little bit bigger because you're 2110, but you haven't really instituted new workflows. Maybe you can get some higher usage of equipment because you can treat it as virtualized resource, but still you don't have new workflows. It's just existing workflows bundled together. So another part about this is, and this is slightly to what you're talking about, is a lot of the stuff today is not optimized use of compute. I was poking fun at TAG for our MCMs. We took something that was on a pizza box with its own database because it was designed to be on its own server. We put it to the cloud. All of a sudden, we've got hundreds of instances of database running. Highly impractical. We've also seen a lot of companies using massive amounts of GPU today to do video switchers in the cloud and to be able to do software-based video switching and software-based audio processing. And there's some things that GPUs are fantastic at, especially like frame rate conversion. The individual pixel tracking of frame rate conversion. GPUs are fantastic at that. But a lot of time, I think the companies are just getting lazy by using the tools that are available to them with GPU. And we're going to see an industry in a short period of time, not now, but in 5 to 10 years, where it's going to become CPU. It's going to probably become closer to ARM than what we have today with Intel, because we want it to be more efficient. So we have massive amounts of GPU being used today. If you guys look at the pricing of GPU and AWS compared to CPU and AWS, it's almost an order of magnitude more expensive. It's ridiculously expensive. So this goes back to, if you're going to use a legacy software solution that requires a ton of GPU, but you're going to put it in AWS, and now your compute costs go up by an order of 10, you really done anything good for yourself or the industry? Or have you just made your product work in software? That's what we're seeing. We've just had a lot of people make their product work in software, but they haven't actually done anything different, done anything new. So this is kind of where we're at today, is now we have to optimize the infrastructure by having software design using modern solution architectures. So I'll talk about TAG. Just because if I'm going to make fun of myself, I'll also build ourselves up a little bit too. So this MCM product that we talked about, it had its own local database. Well, if I'm in AWS or if I'm in Azure, they have their own databases that are hosted there. They're high availability, and you can use them for just a fraction of $1 to be able to use their database engines. Why don't I strip the database out of my software, strip all the stuff that we had for legacy APIs and things like that, I strip everything out of our solution. And all I do is I now have a piece of software that is 100% process function oriented. I'm going to take in a whole bunch of signals. I'm going to run the proprietary stuff, the monitoring, the probing, the signal analytics, the ability to create multi-viewers, proxies, and all the stuff that we need to be able to do a workflow. Keep that in our software because that's what makes us unique. That's what the industry needs. But stuff like API controls, API harnessing, orchestration layers, databasing, all the backend stuff that we've had in our solutions, strip it out, put it in a high availability environment, and let the cloud do what it needs to do. Or if it's on-prem, run your own on-prem databasing, run your own your on-prem HTML5 interfaces, all this kind of stuff. So you want to be able to strip those legacy softwares down to the most basic elements and have those basic elements be orchestrated and deployed wherever the compute needs to be. Accurate? I got the guy here who can keep me in check and make sure I'm not being a sales guy here. So that's got to be the goal. But what we're seeing, and what you were talking about, by the way, right now, there's actually almost four companies doing what you just mentioned. You have Grass Valley Amp, which is doing that. AMP, you can take in almost any source, 2110, NDI, SRT, that kind of stuff, and they put it in their own proprietary frame cache. And when they put it in their own proprietary proprietary frame cache, they use a fantastic technology called RDMA to be able to share those resources across multiple compute nodes. So you guys may have heard of a company called Matrox. Matrox has a product called Origin. And Origin is, Matrox traditionally was a hardware card that will allow somebody who wrote software to get it into SDI or get it into 2110. Well, when this happens, those cards, they'll be around for a while. Don't get me wrong, I'm not saying it's like a 5-year death, but their life is limited. So Matrox is like, holy crap, what are we going to do? we have to get new business. So what did Matrox do? They created Origin. What is Origin? Origin takes outputs of software from any vendor using any context of video and audio metadata, and they put it into an RDMA frame cache. Kind of the same vibe of technology. Now they do a lot of special stuff about asynchronous and synchronous video and things like that, but they're kind of doing the same. NVIDIA, Holoscan, thank you. We're going to take all this media, we're going to run it through the GPU, and guess what? We're going to make it all work together via an RDMA. Same thing. This is happening again. Now, the 3 companies I've mentioned, fantastic products, and they work. I have no complaint about that, except I'm a very small vendor. If I want to be on any of those platforms, I got to pay. I got to pay those vendors percentages of my sales to be on the platform.
No, for Holoscan.
There's no such thing as a free. There's no such thing as a free ride on this boat. So, but that's the reality where we're at. And so, me as a small vendor, I'm not really keen on giving up a percentage of my margin to my competitors, or Matrox, not so much a competitor, but I'm not. As a sales guy, I don't like giving up margin. I'm just being selfish. But it also makes me not want to go on those platforms. So there's these platforms out there that did exactly what you talk about, where they take in video from all the different kind of codecs, all these different kind of standards, all these different transports, and they put it into a frame cache or an RDMA shared memory situation and allow them to do that. Well, how do we do it in an open manner? And this is the interesting part. This just came out 2 months ago. It's a killer document. I highly recommend you read it. It's not terribly long. It's like 22 or 28 pages, something like that. And it talks about, it's by the EBU, and it's a dynamic media facility. It's a reference architecture, not a standard. It's how to stitch together some technology in this environment and how to get these to all work together. Again, it's a fantastic read before you go to bed, but it's also a fantastic glimpse into what this future could be if we all work to open standards and we all work to open protocols. So, sorry, so I could go take pictures today. Jump ahead.
One add on here too. Can you jump 2 slides back? Yeah, perfect. Thanks. Another big benefit or pro is if you're using in your software architecture modern solutions or standardized containerized solutions. The example is with a database on every single instance, right? And then you can externalize that with your customer. From our vendor perspective, you externalize this also out of your responsibility. The customer has their database running in AWS, and you just plug in the 600 instances to their database, and you are out of the responsibility. So that's also a big pro.
Yeah. But think about this from the good perspective on this. Where does that leave the broadcast engineer in this domain? Now I'm hooking into, as a broadcast engineer, I'm hooking into an IT supported on-prem or AWS enabled database. What does a broadcast engineer today have to do to still have a job in this environment in 5, 10, 15 years? It's kind of a big question that everybody's having to face. So thank you. Anything else on that one? Okay. So yeah, dynamic media facility. Again, I originally did this presentation for a much smaller group, and this, honestly, just talking about this EBU paper could very easily be like a couple-hour rabbit hole that we go down. There's a lot of new concepts that this industry hasn't had before to work through. But interesting part is it's a totally new model of referencing and timing. You look at how important reference has been, and actually about 99% of what I know in reference, I'm going to blame it to this guy right here because he's taught me over the years. So I don't want to get this wrong. He used to be like, you have failed me so much if I screw up this point. But you look at reference and timing. So you go back to the SDI days, and especially the analog days, but definitely the SDI days. We're talking pixel level timing accuracy on this. We're getting that accurate on some of these switches. So we had very accurate time clocks inside. Then 2110, we go to PTP. We kind of loosened it up almost by an order of magnitude. Now we kind of care definitely about frames, but we kind of care a little more about lines and that level of accuracy on PTP, even though PTP is way more accurate than we actually need it to be for what we do. Going to the EBU model, we're actually walking away from PTP, and that level of clocks, another order of magnitude looser, because now we just care about frames. We want to be able to see the top of frame, but the top of frame in a non-synchronous model is different than what we've always used, because we've always worked in a synchronous model. We always wanted top of line, top of pixel, top of line, top of frame to always be perfectly aligned. Because just historically in hardware, we haven't had a lot of buffer, and buffer adds delay. So like in routers, you know, we had input buffers on routers, but that added a frame of delay and an enormous amount of cost. So we just didn't do every input as a buffer, right? We wanted as accurate as we possibly could. Same with 2110. You know, we've got a little bit more buffers on 2110, especially for some, to make up for some jitter, but we're still, you know, not burning up entire frames worth of buffers to time align everything unless it's an actual dedicated frame buffer. Well, when you're using compute where you have enormous amounts of memory, enormous amounts of bandwidth, especially now that PCIe 5 is out, and we're very close to have a PCI 6 where the memory bandwidth is almost more than what we can use today. Do we really care that much about hyper-accurate clocks? And do we really care if we have to buffer it a little bit, since the amount of memory we can use for buffer is enormous? So the CBU paper actually spends quite a bit of time saying that we can kind of walk away from PTP, the accuracy of PTP and the accuracy we traditionally have, and now using things like NTP, which is a very generic IT-centric timing protocol to reference our clocks, is good enough. And I don't know if you guys know Paul Briscoe. I know you know him. I got Paul Briscoe in my ear all the time saying that PTP is way too accurate and it makes things harder than it needs to be. So if you hear a little bit of a bias in that, is because I've got a little Paul Briscoe in my ear complaining about the over accuracy or the overly sampled accuracy of PTP. So, but very much along the line, this is it's asynchronous coming into the platform. Because when the video comes in, you know, if it's a HEVC, depends on the GOP structure, it's not frame based. So we're kind of blowing that out. If it's MPEG-2, again, depends on the GOP structure. It's absolutely not, I mean, unless it's iframe, but still almost nothing is unless you're doing nonlinear, just coming to your background. So the idea is now we're dealing with a large amounts of asynchronous video and audio metadata. But we have enough buffer in the platform because there's an enormous amount of memory and compute at our fingertips that we can, I hate to use the slang term, we can clean it up in post now. We used to not be able to clean it up in post. Now we can't. We can buffer it at the output, buffer at the input. We can add the buffers to the alignment wherever that workflow requires it. Because do I need to buffer a whole bunch of, or do I need to time align a whole bunch of video just to be able to put it into a multiviewer? Not really. Oh, there's a lot of others. It's like if I'm going to do a video switcher, I need super accurate timing, you know, top of frame, that kind of stuff to be able to do an accurate, clean switch. But if I don't have to use the buffer, if I don't have to use the CPU to do a synchronous workflow, then why? That's kind of the domain we're at. We can pick these workflows of this is where I need the video to be perfectly synchronized. This is where I need it to be time aligned. This is where I need things to happen in a very predictable manner. And other workflows where it just doesn't matter. Basically, any distribution workflow, anything after a creative decision has been made, do you really care? Do we have to really care? We only really care about the synchronized workflows is when people are creating content or they're making decisions, production switchers, audio consoles, things like that. After that decision has been made, for the most part, we can go back to asynchronous and nobody's going to care or know and save you a bunch of money while doing it. So that's a big implication of this and totally new for our industry. The other part that's really interesting about this is so we'll use, I'll use Grass Valley, for example. It's an easy one. They have a GPU instance spun up that it's a fantastic production switcher. You know, it's got the concepts of MEs, even though it's all software emulated, but it's got the concepts of MEs where TDs can use their panels and they can use the environment they've always had, right? Now, that uses a bunch of compute, uses a bunch of GPU and so forth. Almost for production switchers today, you almost kind of have to still. But that's still kind of a legacy model. You know, what is, well, I'll dive into this part in here a little bit. But the goal is going to be, I want to be able to take that old Grass Valley compute, that is a switcher, tie a control panel to it, but maybe if I have to do an up-down cross conversion, but I really like AJA's math I think it looks fantastic on that. Well, I want to be able to plug in your module, be able to do that. And maybe I want the monitoring and probing from Telestream to be able to tell me what is the health and status of my hundreds of inputs and outputs coming out of that. The goal is, and maybe for audio, maybe Euphonics makes a fantastic audio processor somewhere, or Audinate has a plugin I want to be able to use. The goal for this is to be able to have an architecture that's open, that has common APIs, secured. By the way, ClearText, there's a couple of vendors in here. Kill ClearText, or it's dead. Just go to, fully encrypted APIs, REST API based. And this allows you to take a little bit from one vendor here, a little bit from another vendor here, a little bit from a vendor here, orchestrate it over a common orchestration layer, and there's your workflow, which is something kind of what we've been doing for the past 50, 60 years. I'm going to take an AJA device, SDI cable into an Invision router. I'm going to take that with an Invision router, plug it into a Grass Valley switcher. I'm going to take this Grass Valley switcher, and so on and so forth. We've had this style of workflow, but we've never had to deal with the orchestration and the compute and the resource management stuff. And this is what the EBU does. This allows you to create those dynamic workflows with multiple vendors as you see fit. And that's the big goal of this. So it creates a new media exchange platform and a processing stack, as I just explained. And the interesting part is it works via RDMA over converged Ethernet. So RDMA is a way of sharing memory across multiple devices. Now you can add that over Ethernet. One of the biggest complaints, I had David Ross chewing at me a little bit last week about this, saying, well, I get it, but Rocky doesn't work over WAN. You're right. But there actually is a RDMA Rocky-based exchange format that has FEC and ARQ built into it now. Right? Like ZWZip. I forgot exactly what it's called, but there is now a version of RDMA that is designed to work over WANs. It's got error correction in it. It's got flow management and all that kind of stuff in it now. So now if I have shared memory on software processes that can work on-prem or in the cloud and using WAN-capable RDMA interfaces, now the only thing that's the functional limitation to creating this workflows is how much bandwidth do I have between my compute nodes. That's it. It's still something that has to be worked on. Now, I'm not saying this is that we have no problems to work towards here, but that's kind of the new challenges that we're having to deal with. So I'm sure everybody here has been around the OSI stack or seen an OSI model over the years. This is kind of their new model of this, and this is ripped straight off of their presentation. But the idea is it's stuff, I don't want to say we don't care about, so I'm overly generalizing, but the stuff we don't want to care about. Infrastructure, host platform, and container platform. Abstract that from the workflows, because infrastructure, that's the CPU I have, that might be the GPU that I require, but primarily CPU. We want to be able to abstract from the infrastructure, the host platform. Do we want the operators, do we want the engineers to really care if it's on AWS or Azure or on-prem, work on a virtual machine or on a pizza box? Ideally, abstract that out. And same with container platform. If it's a virtual machine, that's, you have your hypervisor. If you're going to do an AWS, you might have Kubernetes, you might have all sorts of, I can rip through a whole bunch of ones that handle all the containerization. We want to abstract that out because that's not industry specific. That's every company that makes stuff that runs on IT. So then things like media exchange, media functions, and application and UI, that's what really matters. Media exchange, how do we allow these different workflows to talk to each other? Send media between them. Media functions, higher level processing. Well, I've got some media here that's 1080i, but my workflow is requiring UHD. I've got to do an up conversion. Or I've got a SDR input, but I'm a Dolby Vision PQ output. There's a functional delta, so I need to be able to spin up a process to be able to make that work. And lastly is the application and UI. Again, I'll talk switchers because they were in Grass Valley and it's easy. You think at TD, you sit in front of a Grass Valley panel, cares if it's a whole bunch of FPGAs or it's a bunch of CPU running AWS, as long as when he pokes the button, exactly what happens. That's the goal. But not to overly simplify it, there is parts that go over, and this, again, the document goes into quite a bit more details about this, adding security, control, monitoring, and provisioning, because we want to be able to tear down events when we don't need them and create new events when we do need them, because we don't want to have, at peak, I might need 200 nodes that compute in AWS. I want to run 200 computes of compute all the time. I want to be able to shut it down to 1 or none or 10 or 15 or, This is an adaptive infrastructure for provisioning, so that has to be part of it. And control and monitoring. How does the system know to spin up these nodes, spin down the nodes, tend to all the parametric values? Okay, hey, processing node, you are going to be a 1080p to 720p downconvert. How does it tell that? How do we orchestrate all those API commands that need to happen? And also security. You want the system to have the absolute bare minimum functionality and user applications that they can to get the workflow done. So how do you limit it? So it's all part of it. And this is a little more graphical part. Everybody in this audience I know is actually pretty top tier what we do. So this slide's a little basic. But when I was presenting this last week, it was primarily to a lot of like TV station engineers and things where SRT is kind of a new concept. And so I wanted to be able to kind of give it a very high level. But the idea basically is you have your overall UI. You have two media functions. I have one source that's something, and I need to exchange between the two, and I need to do another function. And then you got your container, which is the abstraction of the computer. That's the simple part of it. But this is the last part, just to have a little fun, but also kind of paint a picture of where the industry is going. If you have a software environment that's properly designed, what's the difference between a multi-viewer and a switcher? It is transition control, but that's just a microservice, or is a service that can be spun up to do that. So I'll use the tag thing, for example. You look at, well, there's nothing. We need DVEs, and we need MEs, and we need graphics, and we need overlays. That's what we need for production switcher. You don't do any of that in multi-viewer, don't we? I mean, look at this right now. Let's say that's a 1080p output. It's a 1080p input. So I just did a scale down to make that little pip right there. Doesn't that look remarkable like a DVE? What is DVE? Somebody set the functional values of what this video is going to do, and they overlay it on a screen. That multi-viewer right there is doing a lot of. So we have the concept of DVE. We take a video, we process it, we squeeze it, we change parametric values of it, but we're still doing it. Now, let's talk about graphics. Well, graphics today is you have an external box made by Ross or by Chiron or whatever, that it takes in text from somewhere, renders it on a screen, and then brings it in as a key fill. Well, there's whole companies, or very small companies like Singular, that do HTML5 graphics on the fly. And they're just as rich as anything that Chiron, and just as rich as anything that Ross could ever do. And it's HTML5 commands that are being sent to a compute engine, and that compute engine just renders an HTML5 as your phone does, as your computer does, as anything else it possibly does. So, well, rendering HTML5 is super easy. I mean, this box runs Linux, right? That's easy. So graphics are done. So we have DVEs, we have graphics, we have squeezes. Now we don't have UI. That's a big part. That's a hard part. Honestly, I think that's the hardest part. But if a multi-viewer can be broken down into its most core bits, I got this little window right here. That's a squeeze. What's the key from using that same engine to composite 2 or 3 on top of the screen, add HTML5 graphics, and boom, this multi-viewer minus the transition engine, which is the hardest part, now has all the capabilities of a very small switcher. It's the same components. We're just taking the video and audio, breaking down into the most elementary possible functions, and stitching them together with a workflow engine. This is what we can do. Once we get away from the uncompressed domain, once we get away from kind of the fixed environment we're at, you can start stripping these down to the most basic element and create whatever workflows you want using the exact amount of compute. Modern switchers today, we've always known switchers as 32 inputs, 64 inputs, 128 inputs, right? I can't say who it is for very obvious NDA reasons. There is a customer today who owns a whole bunch of news affiliates who have the goal in the next 2 years to remove production switchers from all of their news production. And they're doing it because the capacities of graphics boxes for the scale that news needs it is enough for them. Because you look at a news shot, what is a news? You have a camera, over the shoulder video, which is like a live shot or whatever. So there's 2 video inputs. You have graphics, but graphics can be rendered in HTML5 directly to that. Well, you have a chroma key, but that's just a function inside of the box already. So you go through most, worst case scenarios for news. 5, 6, 7 inputs are used on the screen at any given time, which means if you want to preset the scene before, you need 14 inputs. Almost any graphics box system can do 14 inputs today.
Right, so you're still kind of at the master control level. Traditional master control
Yep.
versus, 5ME.
Exactly.
Gigantic.
But you look at the percentage of productions that are 9ME, 32 videos like NASCAR productions. NASCAR and golf are usually the two heaviest users of switchers in terms of I/O. That is a fraction of a percent of all productions done. If you look at schools and churches and news and anything like that, this is actually beyond the 80-20 rule. This is probably closer to the 95-5 rule. 5% of the people need the giant box switchers. The other 95 are going to be entirely happy with a 3-input, 4-input, 5-input, 12-input software instantiated switcher. That's it. Thank you all for the time.
Thank you, Robert.